In this video, we're going to talk about the stereochemistry, the stereochemical outcome of these reactions. Here we are looking at electrocyclic reactions. I haven't drawn the metals yet. We're going to figure this out. So now what we have here is a try-in. And notice the configuration of the double bond here. This is, see, this chain is opposite to that, so that is E. In the central part, this is Z, and this here is also E. The central part here is exactly the same, so is C, but now let's look at this, look different to that. Here, the double bond, if you see chain in one side of the double bond, let's say, and this is opposite side, so that is the E configuration, and here at this double bond, this is same side, the two-side chain, so this is Z. So notice the difference here. This is EZ, and this is EE at the side. So now we need to see what are the conditions here. The reaction, let's say, is happened under thermal conditions. And we know from what we did in previous video that if we have an electrocyclic reaction, say involving 6 electrons, say 6 electrons, and the condition is thermal, this will happen in this rotatory fashion. This rotatory. Okay. So having said that, what is this rotatory? Let's remember, this rotatory is moving in 2 different directions, either inward or outwards. And cone rotatory was moving to the same side. This is like the windshield wiper. Okay, so having that clear, we know this is going to happen in this rotatory fashion. Now, these 2 metals are like pointing outside, right? If we see that. So if this is happening in this rotatory motion, meaning opposite side, again, these 2 fingers is the metals pointing outwards, right? As we saw in the configuration. So moving in opposite direction, because it's this rotatory will be doing this. So either this or back, right? So the end result is, again, if we have the 2 metals pointing opposite in the double, in here, one this and one there, moving this rotatory fashion will give me the 2 metals to the same side. So at the end, I am going to have the following. Just kind of drawing in different colors. And this compound here is a meso compound, so the enantiomer will be the same. So it is important. Here we will have one product. And this is meso. Okay, let's use another. All right, now, what happens, again, the stereochemistry is what we're studying here. Now here we have E, so if in this case we did this 2 like that, here, this, I'm going to say, is this side, and this is like that, pointing like inwards, let's say. But now the movement is this rotatory. So when I do that, let's say that I do this to this direction, then the other needs to move to the other direction. So I'll do it again. In the plane, this is this finger pointing outwards, let's say, and this inward. Moving this rotatory is opposite direction, so this going in this direction and this in the other direction. That will give me the 2 fingers, say, pointing opposite sides. So the end result is that I'm having this on dash, the metal, and this on wedge. And this is a chiral center, that's a chiral center. This compound has an enantiomer, so we can have that plus the enantiomer. So at the end, notice it is important when we are predicting products. In this case, if we move in this rotatory fashion like this, in the case of the EE, we have 1 compound. Either we get the 2 up or down, but it's the same, it's a meso compound. Not the case here. we're generating two chiral centers, and that's not meso, so you will have an enantiomer. And again, the movement here was if I have this pointing outwards and the other is inward, moving opposite direction. If this goes this way, the other will go that way. But you can do also the other rotation. So that's why you get here a mix of two enantiomers, and here you get one.